All right, so tonight we're going to look at quadratic stuff. There we go. We're going to start looking at a lot of stuff with quadratics first. So quadratic equation, quadratic functions, and parabolas all work together. So when we're looking for solutions, roots, zeros, x-intercepts, all we're looking for is those are all the exact same thing in concept of what we're looking for. So for the first couple problems that we're looking at, they're literally looking just for the solutions. So if you got a problem like this, it might be easy to factor it. So if we want, we look at this one, we're going to look at factoring. So we've got w squared minus 9w plus 14 equals 0. So we're looking for two numbers that multiply to 14 and add to negative 9. So in this case, I've got
2 and 7.
Yeah, exactly. So, and they're both going to be negative, because the negative 2 and the negative 7 will be the negative 9. Now that we got those, we just solve them for 0. So w equals 2 and w equals 7. And then those would be my answers to the problem. And just put a comma between them. So that one was really easy because we could factor it. When you have a number in front, sometimes we can factor, sometimes we can't. We have 5u squared plus 8u, and we have to have it equal 0. So you want to bring the 3 over. So we got plus 3 equals 0. So whatever's on the other side, we want to bring it over to make sure it equals 0 so we can do it as a quadratic. So when you have a number in front, I always like doing it, factoring by parts. So I'm looking for two numbers that multiply to 15 and add to 8. So I've got 5 and 3. So I've got 5u squared plus 5u plus 3u plus 3. So I take out the 5u, and I've got u plus 1. I take out the 3, and I get u plus 1. So my two factors are 5u plus 3 and u plus 1 equals 0. So that's known as factor by grouping. I'm basically just breaking up the number in the middle to the two pieces, and then I'm factoring out the two sides. There's many different ways you can factor when there's a number, when there's an a greater than 1. This one I just seem to like. It's quick, easy, it's formulaic, and it always works instead of the guess and check method that some people do show. So, and the same thing we have to do. We have to solve each of these for 0. So I've got 5u equals 3, or negative 3. So u equals negative 3/5, and u equals negative 1 as my two answers.
Professor, can you leave that up just for a few more seconds?
Yeah, sure. I wrote that one pretty quick.
Thank you.
No problem.
Okay, thank you.
No problem. A lot of these topics are very similar, so I'm not going to do multiple ones of the same problem, just because I'm going to cover some of the same stuff in the next problem. So, all right. So now this one, it says in the problem, you use the quadratic formula. So use the quadratic formula, because if it says use the quadratic formula, it means it's not going to factor nice. So definitely do that if it's telling you to. How I like, so depending on how they want the answer, if it just wants it as a decimal, you can plug it all into a calculator and get the answer. If it doesn't want the decimal, and this one doesn't, it actually wants it in simplified form, it's actually harder to do it on the calculator because of the way it's going to work out, give you the answer. So what I do, so the first thing is the quadratic formula, if you don't remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I like to do is I like to do the inside part first. So I'm going to do the b squared minus 4ac. So I've got negative 9 squared minus 4 times 3 times 3. No, times 4, sorry. So 81 minus 48 is 33. So it's the square root of 33. What by doing that part first does is first it gives me the square root so I can simplify it down if I have to. It also tells me if I'm going to have any complex roots, because some of the topics you're going to be doing have complex roots. So we would have the I put in place as well. So it just does all that part first. It also finds me the discriminant and does those things as well. So it's nice to do that piece first. Also, when I plug back into the actual equation, it's a little easier to write. So now all I have to do is this negative 9 plus or minus the square root of 33 over 2 times 3. So it's a lot easier than putting all that inside here and having to write the quadratic formula numerous times. So we got x equals 9 plus or minus the square root of 33 over 6. When you type the answer into Alex, it's not going to let you put the plus or minus, so you have to write the answer twice. So what I would do is I would do the division first, and then do 9 plus square root of 33 over 6. And then the other nice thing is you can copy and paste. So you can copy and paste it and then put the minus there. So you don't have to rewrite it. And now let's see if I messed it up. I got it right. Good. So those are little tricks to make life a little bit easier when you're doing the quadratic formula, is just do the b squared part first and then plug it back into the quadratic formula. Now this one, it says round to the nearest hundredth in the problem. So this one's going to make it as a decimal. So if you wanted to, if you want to use Desmos, or if you just want to use the graphing calculator or the calculator that they give you, you can type the whole quadratic formula in this in one shot. So we can do negative b, which is 9, and then plus and square root 9 squared minus 4 times 2 times 5, and then highlight it all, divided by 2 times 2. And it'll give you your answer. So this one is negative 0. And they went to the hundredth, so 6, 5. And then you just hit undo. And then we can change that plus to a minus. And get negative 3.85. Nope, because I moved the 5 over. So it's after the equal sign. So the actual problem I'm solving, or I'm going to plug into the problem, is 2x squared plus 9x plus 5 equals 0. Is actually what I'm plugging in. So the key, like the difference between this one and the other one was this one has the nearest hundredth, so we're going to choose the calculator. The other one, we needed the exact answer. Now this one says complex solution. So this one, we know we're going to have an I. So again, same concept. I would do my b squared minus 4ac part first. So I've got 3 squared minus 4 times 1 times 4. So 9 minus 16 is -7. So it's the square root of -7. So then x equals -3 plus or minus I square root of 7 over 2 times 1. So it's x equals -3 plus or minus I square root of 7 over 2. When you're typing this in, notice I put the I in front of the square root, and I will show you when I'm typing this in why, because it's really easy when you're typing it to actually mess up and put the square root over the. So if you do the square root first, and then you put the I, see how the square root is over the I? That'll mess you up. So if you put the I first, and then the square root of 7, doesn't have that problem. And then we're doing the same thing. We have to do the plus or minus to that one. All right, so that was the end of the quadratic formulas ones and finding the solutions. Any questions on those before I go on to finding vertexes and stuff? All right, I am going through the first stuff, like this stuff, pretty quickly, just because I know the stuff towards the end is going to take a little bit more time. So, all right, x-intercepts. Remember what I just said. X-intercepts and solutions are the exact same thing. So to find my x-intercepts, I'm doing my quadratic formula or factoring it out. Your vertex, you can always use the formula x equals -b over 2a. That's going to give you your axis to symmetry, which will give you your x value of your vertex. So it's probably the fastest way to do it. Sometimes in the examples, I'll show you to turn it into vertex form. I think it's faster just to actually do it this way. So I've got -2 over 2 times 1. So 2 over 2. So x equals 1 for my vertex, and then I plug that back into the problem to find the other value. So 1 squared minus 2 times 1 minus 3. So 1 minus 2 minus 3 is -4. So my vertex is 1, -4, and that's my vertex. My x-intercepts, if I can factor it, let's factor it. So I've got x squared minus 2x minus 3. That breaks down into -3 and a +1. So -3 and a +1. So x equals 3 and -1 for my x-intercepts. So they have the answer written. They just have a box for the x-intercepts and not a point. So you can type the numbers in, and it doesn't matter the order. And then your vertex, they want the actual point. So that's 1, -4. The other way you could find your vertex is if you find your two x-intercepts. If there is 2, it's going to be right in the middle of those two x-intercepts. So if we look at 3 and -1, the number right in the middle of those two is 1. So that's another way to find that x point there. It's also a way to do a quick check to make sure you actually have the numbers all right. If I'm going too quick or you want me to put something back up, just ask. This one's the same thing. It's just adding an extra piece to it. This one's adding, it does have a minimum or a maximum value. So A tells you that. So if A is positive, it's a min. And if it's a negative, it's a max. So in this case, A is 2. So I have a minimum. And then where does the minimum or maximum value occur? And what value is it? That's your vertex. So I'm just going to do my vertex for this one. So x equals -20 over 2 times 2. So x equals -5. And then we plug that back in to find the y. So we get 50 minus 100 plus 46. So y is 4. Now these right here will switch a lot of times in these problems. So as we were talking about before class, that it's really easy to make little mistakes. And Alex, reading is very important, and looking at how the answer is worded is very important. So they will switch these up on you. So if you're just doing it quick, you always type it in the right way, you'll have the right answers and you'll have them in the wrong boxes. So the X will always have an X equals in it. So that'll tell you which one's going to be the X, and the Y won't. So you're just going to put the value in for the Y. Okay, and now I messed up. See how easy it is to mess things up? Oh, it's -4. See what happens when you rush. You make little mistakes and you have to do the problem again. That should have been a -4. All right, graphing the parabola. So when you're graphing it, they only want 5 points. It actually doesn't matter what those 5 points are. So the key that you want to find, your axis of symmetry, and just find 2 numbers on one side of it. So in the vertex. So the first thing we want to find is our axis of symmetry. So I'm going to do the x equals -b over 2a again. So I've got -2 over 2 times 1. So that ends up becoming just 1. So my axis of symmetry is at 1. And my so now when I'm plugging in my values, I'm going to plug in do an XY table. And 1 is going to be the first number. And then I'm going to do 0 and -1, just because I like plugging in the zeros. So now we're just going to plug those numbers into the problem. So got 1 minus 2 plus 5 is 4. 0 is 5. Then I've got 1 plus 2 plus 5. So -1 is 8. So my 3 points, so we're going to graph my 3 points. So you can use the pencil tool or the actual type in. I would suggest using the typing tool, just because this, especially if they're going to end decimals or fractions, it makes your life a little bit easier. And you got it exactly where it's supposed to be. With the pencil, if you're a little off, you can get the answer wrong and it'll frustrate you. So 1 and 4. 0 and 5. And -1 and 8. Now, I need the ones on the other side as well. So that's just the half of the sides there. So because the axis of symmetry cuts it in half, my other 2 points, if I went the other direction, if I did the 1, 2, 3, it's going to be the same ones. It'll be 4, 5, and 8. So plot those 2 points as well. So I have 2, 5. And 3, 8. And then I click the little curve tool and it should make a nice parabola. So that's why that axis of symmetry comes into play. It saves you from having to come up with the other 2 points. Same thing, it just has a number in front, but it's the same exact concept and problem. So I do the x equals -4 over 2 times 2. They don't always come out to be 1, just in case you're wondering. So I'm going to do -1, 0, 1, and then I'll put the 2 and the 3 in there just so I have them. So the 1, or we'll do the -1. So I've got 2 times, so it's 2 plus 4 plus 6, so it's 12. The 0 is 6. The 1 is 2 minus 4 plus 6 is 4. And then that's going to be 6, and that'll be 12. You can use so Desmos is actually a really good calculator to be able to do a lot of these calculations on. It'll actually graph it too for you. It won't actually give you all the points though. So, but using Desmos, you can actually look at and plug in the values and then just go back and change them, so you don't have to keep doing them every problem. It does make your life a little bit easier, especially if you're a little iffy on actually doing the calculations in your head. I'll show you Desmos in a second. There's a graph, and we have a nice parabola. Let me pull up Desmos so I can show you that real quick. So Desmos has a graphing calculator and a scientific calculator. The graphing calculator will graph it for you. That'll be just like a normal graphing calculator. Scientific calculator actually is really nice too, because like I was saying with this problem, you could actually type in 2x squared minus 4x plus, what was the number? 6. And then what you do is you do x equals 0. And notice how it gives you the answer right there. And then -1. And then 1, 2, 3. And it gives you that answer right up there. So you can type the equation in and then type the numbers in here, and I'll plug those numbers in there for you. I don't have a problem with you doing this because my assumption is you know your order of operations and how to do basic math. I'm not worrying about that. I'm more worried about you graphing the parabola. So this will take care of that basic math thing, and also will solve some of the little sign issues that can come up when you're doing your basic math. The graphing calculator, you can do a very similar thing. You can type in the equation. So 2x squared minus 4x plus 6, and see the graph. But it won't give you every point. It'll give you the vertex. It'll give you the y-intercepts. But other than that, you have to like scroll along to find points. So this is not the greatest thing to use to find your points. This will help you find your intercept points and stuff like that, however, and it will show you that you actually did your problem correctly. So just another tool to use. All right. Moving along. All right, now to the stuff that's a little more complicated. So the first, when we're looking at composite functions and stuff like that and putting functions together, the f and the f of x and the g of x and stuff comes into play. This topic looks really, really complicated. However, as you flow through it, it actually becomes pretty simple. So I wanted to do this one first, and then we're going to do another one. So on this one, what they want you to do is they actually want you to take the line and go through. So let's look at the 1 first. So 1, we're going to start off at 1. 1 goes to 6. And now I'm going to go over here to the 6, and 6 goes to 5. So 1 goes to 5. And then I look at the next number. 2 goes to 9, but there's no 9 over here. So 2 doesn't work. And then I go to the next number. 4 goes to 9. And we know there's no 9, so 4 doesn't work. Then 5 goes to 0. And 0 goes to 2. So 5 goes to 2. Then we look at 6. 6 goes to 9, so 6 doesn't work. 9 goes to 2. And 2 goes to 5. So that's how you would do this topic. So the 5 goes to the 0 is just that line right there. And then that 0 went to 2. So that's why it's actually not 5 to 0. It's 5 to 2. It was just the way it was broken up. Okay. So now when we're doing this, when you're typing your answer in, you're going to type your domain as all the numbers that work first. So we use the set tool, the set notation. So we have 1 worked, 5 worked, and 9 worked. And then the answers were 5 and 2. So 2 and 5. So you put your numbers in, figure out where they go to, and then that's your domain and your range. Whichever ones didn't work, I'm not going to use at all. All right. That was one of those one-off topics that I know frustrates people, so I wanted to make sure I covered that one. All right, so now this topic, this is where we start to put functions together. So basically, this piece over here. So when it says, that first one says r times s, all I'm doing is multiplying the two functions. R plus s, I'm adding the two functions. R minus s, I'm subtracting the two functions. But this one, notice the first two have the x. This one has a 4. So they want me to subtract the two functions and plug in 4 to them to find the answer. So this one's expecting an actual numerical answer at the end, where the first two are actually just expecting the equations. So r times s of x is 3x minus 6 times 4x. And you can leave it right like that. You do not have to distribute it out. So when I'm in the box here, I can type in 3x minus 6 times 4x. And I can write it just like that. The r plus s, same thing. I'm just going to write 3x minus 6 plus 4x. You do not have to simplify it down. You can. So that one would be pretty easy. You could do 7x minus 6, but you do not have to. The subtraction one, we're going to plug in the 4. So we might want to actually do this one out a little bit more and make it a little easier on us. So we got 3x minus 6 minus 4x. So that's negative x minus 6. So then I'm going to plug in the 4 to this problem now. So it's negative 4 minus 6. So it's negative 10 is my answer for this one. So notice how it says the answer is correct, however, it can be simplified. That was what I was saying. You can simplify it, but you don't have to. Yeah, and honestly, you can simplify them all. However, it just adds that one extra piece into play that where you can screw things up. And there's lots of other places you're going to screw things up later on. Take advantage of this one. All right. Next one. So now this one is f divided by g. So we're going to divide these two. And then we're going to plug in the negative 3. So, but they're also asking me for the values that are not in the domain. So if you remember from, I can't remember if it was the last class or the one before that one, we actually did the domain values and figure out how to solve them. So you're going to need to do that in this problem as well. So my function f over g of x is negative 3x squared plus 5 over 5x minus 8. So the 5x minus 8 is in my denominator, and that cannot equal 0. So my domain, 5x minus 0, cannot equal 0. So 5x cannot equal 8. So x cannot equal 8/5. Now, notice in this one, they're not asking you to do the set notation and everything else for it, or the interval notation. They're just asking you for what's the value that can't be in it. So in this case, it's just 8/5. And now I'm going to do the other one. We're going to plug in negative 3 to the original problem. So I have negative 3 times negative 3 squared plus 5. So that's 9. Negative 27 plus 5 is negative 22. 5 times negative 3 minus 8. Negative 15 minus 8 is negative 23. So it's 22 over 23. So addition, subtraction, multiplication, division, all the same concept. You're just basically plugging the equations in. The only difference between division and the first three is the division we're adding in a domain restriction because we're going to be dividing and our denominator cannot be 0. All right, so now this one, it's f minus g of x, and they want to know the domain of f minus g. We just said when we're doing division, we have a domain restriction. The reason why we have domain restrictions in this one is because one of my functions is a square root. Now remember, square roots cannot be less than 0. So let's find that domain restriction first. So I have the 3x minus 4 has to be greater than or equal to 0. So 3x has to be greater than or equal to 4. So x has to be greater than or equal to 4/3. So that is my domain of the g of x. The f of x has no domain restriction. It's just a simple linear equation. So I don't have to worry about that. Now, when we're typing the answers in, same rules apply. I don't have to simplify it down. So I can put in 5x plus 1 minus the square root of 3x minus 4. The multiplication one, same thing. 5x minus 1 or plus 1. And then times the square root of 3x minus 4. My domain, they wanted an interval notation. So since it's greater than or equal to, that means it's going to be a bracket 4/3, comma, and it goes all the way to infinity. And then it's a parenthesis around the infinity. So, and that's going to be the domain of both of these. And you can copy and paste. So you can start to see with like these topics how the stuff we did in the last couple of classes have built on, and they're now using that. So in Alex, the way that it'll work is if you haven't done the domain problems and the range problems to figure those values out in the interval notation, these topics will actually be locked because it needs the domain. So you'll have to go back and do those topics before these ones will unlock. All right, composite functions. So a composite function is when I take one function and stick it inside of another function. So the first thing we're going to do is we're going to do that inside part first. So I've got the t to the third. So I'm going to do that piece first. So I'm going to take the 2 times 3 squared minus 2. So 9 times 2 is 18 minus 2 is 16. So that's t to the third. Now, that's inside the s. So what I'm going to do is I'm going to take the s and I'm going to put that inside the s, because that was the answer to t of 3. So I got negative 2 times 16 minus 1. So negative 32 minus 1 is negative 33. And that's going to be my final answer. So remember what we were doing with those bubbles that we were going from one side to the other side? That's in essence what we did. We went from the 3 to the 16, and the 16 went to the negative 33. So the answer I want was negative 33. So you work from the inside out. All right. That little circle in the middle there. Oh, sorry, not Z, not G, Z, Q. That little circle means composed of. So what that means is it's a Q and then the R is inside. So that's what that means. So just like we did in the last problem, we do the R part first, then we plug that answer into the Q. So this one's negative 5, so R of negative 5 is negative 5 squared, which is 25. And then we plug the 25 into the Q. So I get 2 times 25 plus 2 is 52. So that first one is 52. Now the next one, the R composed of Q, is the same thing except it's reversed. So R composed of Q of negative 5 is R with the Q inside. So I've got to do the Q first with this one and then plug it into the R. So I do Q of negative 5 plus 2 is negative 8. And then I do the R of the negative 8. So negative 8 squared is 64. So the next one will be 64. All right, give me 1 minute. Okay, I think everybody's fine now. All right. So that's where we're going to do the composites. Now, the next couple topics we're going to look at actually puts these together and uses them with the x's, which will make it a little more confusing, but the concept's the same. All right, so you notice how this one's got that x in it. So this one says h composed of h of x. So what this means is we're going to take h of x and plug it into h of x. So h of x is x squared plus 5. So my next one, I'm going to do this in colors because it's actually, so then I'm going to take, really? Change my color. So now I'm going to do the h, and I'm plugging in x squared plus 5. So the first is that x. So where that x is, I'm going to put my original x squared plus 5. And then the squared, and then the plus 5. So this value right here is that original x. So it was x squared plus 5. And I'm replacing it with what was inside that parenthesis there. So the answer, as I put it, would be parenthesis x squared. Oh, they actually want us to simplify this one. It says simplify, so we can't use the parentheses. So we have to actually do this one out. So when we do this one out, we're going to get x to the 4th plus 10x squared plus 25 plus 5. So x to the 4th plus 10x squared plus 30 is my final answer for this one. When you square things, my biggest pet peeve in the world, and luckily for you guys, you're going to be working in Alex, so they're just going to mark it wrong, and I don't have to put little frowny faces next to your answers. X squared plus 5, or anytime when you're squaring things, it's not just squaring the two things inside. I have seen, even in Calc 2 and everything else that I've taught, people put x to the 4th plus 25 and forget the 10x squared in the middle. Do not forget the middle term. It's there. It's important. Don't lose it. So my little pet peeve. So this one is x to the 4th plus 10x squared plus 30. All right, now we're going to do f and f. Same thing. So f of x is 5 over 2x. So when I do the next one, I'm going to plug in the 5 over 2x. So I do 5 divided by 2 parentheses, and then I put 5 over 2x inside of it. So now we've got to simplify this one. So so it's 5 over 10 over 2x. So it becomes 5 times 2x over 10, which ends up coming out to be just x as my final answer. When we do the next couple topics where it's not the same ones, it actually will be a little easier to see. Actually, I'm going to skip that one for a second. All right, we're going to do this one, then we'll go back to the other one. So this one's doing f composed of g of x. So I have the f with the g of x inside of it. So g of x is 1 over x. So wherever I see an x and f of x, I'm going to put the 1 over x. So that means I'm going to have 1 over x divided by and now it's randomly changing colors on me. 1 over x minus 3. So now we have to simplify this problem down. So I have 1 over x on the top, and the bottom is going to be 1 over x minus 3x over x. So I get 1 minus 3x over x. So I get 1 over x times x over 1 minus 3 over x. So my x's cancel out, and my final answer is 1 over 1 minus 3x. For this one. Now, we need to find the domain. So the domain is actually going to be the restrictions from the final answer. Actually, let me check something real quick, because I believe on this one, it's actually not just the final answer, but I want to make sure. Because when I do it, I look at the domain restrictions of all of them, but I think Alex just uses what was in the denominator. Yeah. So what we want to look at is what was in the denominator originally. So in the denominator, I had the 1 over x minus 3. So my domain, my 1 over x minus 3 cannot equal 0. So 1 over x cannot equal 3. And then we have to flip both of them, so x cannot equal 1/3. So that's going to be my domain restriction. So my domain is going to be negative infinity to 1/3. Union 1/3 to infinity. So negative infinity to 1/3. And then 1/3 to infinity. I'm going to check it because I know the error, and I just want to make sure it's actually what I'm thinking it is before I tell you. Yep. All right. This is what I thought it was on this one. So we also, because the other restriction we can have is 0. Because in this original problem here, if that's 0, the 1 over x, if that was 0 originally, 0 wouldn't work either. So that's where the 0 came into play. So you have to look at that whole thing right there. It can't just solve it. You have to look at the pieces of it as well. Don't worry. This one I always get wrong a couple times before I actually because the domains are very tricky on how you do this part. Yes.
Professor, so that means x cannot be equal to 0?
Yes, x cannot equal 0 either, because it would have caused the problem to occur before you even actually solved it for the 3.
Is that partial? Is that also because X is in the denominator?
Well, yeah, it's in the denominator of the denominator.
Okay.
So you're looking at the whole denominator. So the denominator is that 1 over x minus 3. So the 1/3 doesn't work because we solved the problem if 1/3 doesn't work. But 0 doesn't work in my original part, the 1 over x minus 3. So that's why the 0 also doesn't work. Because I also have, if you look at f of x, we have the x minus 3 up there too. And 3 isn't used because that one we haven't actually, we're not using that one anymore. We plug stuff into it. All right, we're gonna go back to 17, and then the last 4 go together. I want to see if I can get this done before my computer dies. All right. So, in this topic, they want you to actually take it and split it apart. This one's one that looks really hard, but it's really simple. All you're ever going to do is you're going to take the piece that's in the middle there, whatever's underneath the square root or in the exponent or inside the parentheses, that's going to be your g. So my g of x is going to be 3x minus 8. And then my f of x will be square root of 3, or the cubed root of x. So all you're going to do for this one is you're always going to take whatever's on the inside and make that g. And then the f will be the stuff on the outside. So that's the 3. And then you're just going to put x on the inside. And it doesn't matter what it is. So like this one's raised to the exponent of 4. So my g is going to be the stuff inside the parentheses. So it'll be f of 5x plus 7. And my f of x will be x to the 4th power. All right, last 4. So what's the slope equation? Anybody? M equals what? Y equals mx plus b is the slope-intercept form, but how do I find slope? If I give you 2 points, how would I find the slope?
X3 minus y1 over x minus x1.
Yep.
Yep.
All right, so that's my equation for slope. So yes, change in y over the change in x. So now, when we're looking at a function, you don't necessarily have the x's and y's, but we can find them. So f of x is going to give me my y values. They're giving me my x's. I need to find the y's before I can plug them in. So the actual format that they're using when they're doing these problems is f of x2 minus f of x1 over x2 minus x1. So the bottom is just 5 and 8, so we got that. So we're going to plug in the 8 to the first problem. So I got negative 3, 8 squared plus 4. 64 times 3, 180, 192. So negative 192 plus 4 is negative 188. And then -3 times 5 squared plus 4. So I got -75 plus 4 is -71. So -188 minus 71 over 8 minus 5. So 1/17. We divide that by 3. And we get 49? No, 39. So it's -39. So even though it's calling it the average rate of change in this function, everything else like that, all you're in essence doing is the slope equation. Just makes it another little complicated way to look at it, but in essence, it's just the slope equation. If they give it to you on a graph, like they do this one, you don't even have to solve it. You actually can just count or look at it on the graph. I'm actually just going to literally count this one. So it's the change in x over the change in y over the change in x. So we're going from 4 to 8. So from 4 to 8. So I'm going down 8. So that's -8. And over 4. So my average rate of change there is -2. All right, last two. All right. So this problem is the beginning of calculus. So when you take calculus, one of the first things in Calc 1 your teacher is going to go over is the limit function. The limit function is taking this equation actually, and for differentiation is figuring out if you crunch it all the way down to 0, like there's no distance between 2 points, what's the slope? That's what you're doing when you're differentiating. That's the beginning of calculus 1. And this function is the concept of that, because this is the slope. As h is getting infinitely small, what happens is those points get close and closer together, and therefore you can find instantaneous change instead of over 2 points. So when we're doing this equation, we're in essence going to be actually finding the derivative of this original function right here. So when you go to Calc 1, remember this equation. So the first thing I have to do is I have to plug in the f of x plus h. So I know my f of x is 3x squared plus 2, 2x. So now my f of x, 3x plus h, is 3x plus h squared plus 2 times x plus h. So now I'm going to put all that together and subtract it on the bottom. So I'm going to have to FOIL this out. So I get 3x squared plus 6xh plus 3h squared plus 2x plus 2h. And then we're going to minus 3x squared plus 2x. So notice how I'm not looking at the bottom. Yes.
Did you say in the middle 2x plus 2h, or is it just 2x plus h? I missed that in the FOIL.
It should just be. It should be 2x plus 2h. I missed the 2. I think I said it, but I didn't actually write it. So now we're going to FOIL out. We're actually going to factor out the h. Or actually, we're going to simplify it down and then factor out the h. So in this case, when we're looking at it, my 3x squared cancels itself out. Oh, and that's minus 2x over there. And the 2x's also cancel each other out. It's minus 2x in the end because you have to distribute the -2. The negative in front of the f of x to both of those. So all I'm left with is 6xh plus 3h squared plus 2. So we're going to take the h out. So I have h 6x plus 3h plus 2. And we're dividing that by the h. So my h's cancel out. So you're left with 6x plus 2 plus 3h. And if you eliminated the 3h, the derivative of 3x squared plus 2x is 6x plus 2. Because when you're doing the derivative, you're in essence making h 0, so the actual 3h would disappear off the problem. But since I have an h in the denominator originally, I couldn't make h 0 until I got rid of that one in the denominator. All right, one more of these. All right, we're going to do the same thing. It's just messier because it's got a division in it. So I've got the f of x is 1 over x minus 9. 1. And then my f of x plus h is 1 over x plus h minus 9. So I have 1 over x plus h minus 9 minus 1 over x minus 9. So got to get a common denominator. So I have x minus 9 minus x plus h minus 9 all over x plus h minus times x minus 9. So my top part of this equation simplifies down to just negative h. Because the x is going to cancel out with that x, and the negative 9 is going to cancel out with that one. And then I have it over x plus h minus 9 times x minus 9. And that whole thing is divided by h. So I have negative h over x plus h minus 9 x minus 9 times 1 over h. So my h's are going to cancel each other out. So I end up with 1 over, or negative 1 over x plus h minus 9 x minus 9. I'm not sure if they're going to take this one as this one or if I have to multiply the denominator. I'm going to see in a second. We might have to multiply that denominator. Nope, they're gonna let me put it. So it's x plus h minus 9, x minus 9. Because you can't actually simplify that down. So it's really the same thing we did in the other one. It's just messier because of the fractions.
So, excuse me, Professor. The final answer is 1 over, not negative 1 over.
Well, it is. There's a negative right in front. Hold on.
Oh, I guess I can't see it.
Yeah, it's there. It's just right in front.
Oh, I see it now. Yeah.
All right. I'm going to stop the recording, but I'll stick around to answer questions.